Hello everyone. So in this particular video, we are continuing with the next topic, next question, which is based on our last video, which is classification of systems. Okay. So I have taken one more numerical. It will help you to get more idea or in depth of the classification of systems. Okay. So you can see here in this particular question, it is asked to test the given system for linearity, causality, stability, and time variance. Okay. Here another system is defined, y of t equals to x of t square. Now we have to check whether the given system y of t is a linear, causal, stable, or time variance. So as we have seen the theoretical aspect of all these classifications in our last lectures, in last video, so we will apply that concept here to determine. Okay, so to begin with, the first I have taken here linearity. So we will check whether the given y of t is a linear or non-linear. So what are the steps to follow? First step is to individually apply inputs to the system and find the individual response. So x1 of t is given to the system. Here t is representing a system response. So x1 of t is given to a system, and what we are getting here at the output, x1 t square, because as per the given system definition, what exactly happening here, it is like a system is there and then you are applying here x of t as an input to this particular system, and what this system does, it makes the time square of it. Okay, so it makes square of the time variable. That's why it is your y of t. Okay, so at the output we are getting y of t. And how we are getting y of t? So this is a property of system that it makes the time variable square at its output. Okay, so we have to apply this concept, apply this logic in this particular steps. So x1 of t, for example, x1 of t is assumed to be one of the input given to the system. So as per the system property, what will happen at the output, it will make square of the time variable. So as x1 of t square we will get at the output. So I have named it y1 of t. Similarly, another input x2 of t is given to the system. Okay, now the same system, so this system will what it will do, it will square the variable time. Okay, so we will get x2 of t square. Are you getting? Here x1 of t is given to the system, we are getting x1 of t square because this is a property of this system, and accordingly x2 of t becomes x2 of t square at the output. So I have named these outputs as y1 of t and y2 of t. Okay, so दोनों का हम लोगों ने नेम दे दिया y1 of t and y2 of t. Now next what we have to do, we have to add these responses, this output. So y dash of t, I have named it, the summation of these two responses named as y dash of t, and that is simply x1 of t square plus x2 of t square. Fine. Now the step number 2. In step number 2, we have to first add these two inputs, x1 of t with x2 of t, and then these added inputs are given to the system. Okay, so first we need to add these inputs, then give the added part to the system input. And now as we know that the system properties is to square the time variable. So individually this x1 of t will become x1 of t square, and this x2 of t will become x2 of t square. Okay, so this is at the output for the step number 2. Now let us compare this step number 2's response with step number 1 response. What we are getting by observing these two equations, that this is x1 of t square plus x2 of t square, here again x1 of t square plus x2 of t square. So both are same. So by comparing equation number 1 and 2, what we get that y dash, this is y dash and this is y double dash. So these two are equal. So and also the system is initially relaxed. What is the meaning of initially relaxed? As we discussed in our last video, that to identify whether the given system is linear, the first step is to identify whether the given system is initially relaxed or not. So for that, we have to assume x of t as the input as a 0, and if it makes y of t also 0, then the system is said to be initially relaxed. So here you can see here कि along with this there is nothing another part. So if it is 0, y of t is going to be completely 0. So this is how your system is initially relaxed. Okay, so system is initially relaxed, first thing. Second thing, the step number 1 and step number 2 responses are equal. That's why as a whole we checked that the given system y of t is a linear system. Fine. Now the next is causality. Now we have to check whether the given system is a causal or non-causal. By definition of causality, a system is said to be causal if it depends on present input value, and if it depends on any another value like future value, it becomes what? A non-causal one. So to be a causal system, system has to be dependent on, the output has to be dependent on present as well as the past value, not future value. Okay, present and the past value, not the future value. So I hope it is clear here. So how I have checked here, see, for instance t equals to 0, y of 0 equals to x of 0. So present value x of 0, उस पे आपका y of 0 डिपेंडेंट है. For t equals to 1, again x1 पे आपका y of 1 है. लेकिन for t equals to 2, y of 2 equals to x of 4, because 2 is here becomes 4, na 2 square becomes 4. So I can see here for this instant time of that is 2 seconds, this output value is dependent on the future value, that is x of 4. That's why the given system is a not causal. So it is a non-causal. Okay, so it's a non-causal one. Now let's check for the stability. For the stability, y of t equals to x of t square, it is given. Now by definition, a system is said to be stable if for bounded input we get bounded output. For example, what exactly this means, if your input is bounded one, means under a limit, then your output, if you are getting a bounded one, again limited one, then as a whole the system is said to be stable one. So you can see here, therefore for bounded input x of t, y of t is a bounded output, therefore the given y of t equals to x of t square is a stable system. Now last, that is a time variance. In this case we have to check whether the given system is a time variant or time invariant. Time variant is what similar to shift variant. So now what are the steps to check for this? Step number 1, see, either you can do this step as a step number 1 or this as a step number 2. The thing is, at a time we have to perform what? I first delay the signal and then pass it to the system and get the output, or first pass that input to the system and then delay it. Okay, let's see one by one. Here in the step number 1, what we have done here, x of t is delayed first. पहले इसको delay करना है. Okay, so x of t is x of t minus k. It is delayed by a k unit. So x of t minus k. Then it is passed to the system, and as we know that the system property is to make the time variable square of that time variable. So you can see here x of t minus k. Now this t minus k is a complete time variable. So here we have x of t minus ka square. Now in the step number 2, first it is passed to the through the system. So by the property of system, this x of t will become x of t square, because square हमें perform करना है time पे, time variable पे. Now we have to delay it. Now this t square is acting as a time now. This t square as a whole is acting as a time variable. अगर इसको delay करना है तो क्या लिखेंगे हम? This is as a whole time variable. Now it is delayed by k unit. So this is we are getting at the as a response of step number 2. Now let us compare this to one. We can see here that these two are not equal. These two are not equal. That's why this is time variant system. So it is clear now that given y of t equals to x of t square is a linear, it is a linear, it is not causal, it is not causal, it is stable, and it is time variant. I hope with this one more numerical, the concept of linearity, time variant, stability, causality, memory, that is static and dynamic, that we have taken in the last video lecture, it is the concept is clear. Okay, so we can solve many more numericals based on the classification of system. Thank you so much.